morning, everybody. Welcome to this day. It goes by a different name this week. This week is called R Week. For those so far we are in this class, it's also the second week of classes and the second day of September. So I want to welcome you, and we will continue what we have been doing last time. And I think people have joined. I always like to start sharp at 9:10. So those who come early, which I appreciate very much, would get a chance to get comfortable. And those who are more punctual and want to start, I don't want them to miss anything. And so we'll get started right now. And I'm going to continue what we did last time. This week is committed to R. Some of you have a little bit of an idea. Others would need the time you need to focus on learning a new programming language. So let me continue. And before I get started, there was something I wrote on the chat session, and I said I will explain later. And that has got to do with something that has got a theme. One of the things that we are discussing now is a data structure called list. And so it's kind of inspired by that, but it has got 4 contents in it. And I typed it because I wanted to talk about it and use it to get to our kind of warm-up question for the day. And some of you have joined late, so you may not see it. I know that one of the people who joined early was Brittany, so I'm going to ask Brittany to type what I typed again, because some of you are not going to see it now. So Brittany, if you can go ahead and type that list equals, and then it has got 4 elements in it: video, audio, content, and comment. And this is what I would like to do as a starting point for our warm-up question. I know I have said in the first class that the technology has worked well and things will be just fine as if we were in class and learning things. And in some ways, there are actually some advantages. But I have never seen how things are working out for you. So my assumption is things are going well. So now we've had a week and maybe half of this week also. And so I want to make sure that the video part of this thing is working well. So on a scale of 1 to 5, you're not going to start writing anything now. Let me first explain, and then you will give me your list. On a scale of 1 to 5, how is the video part of this going on? Some of you might even have watched some of the recordings afterwards, or you are watching it now as it happens. So 1 being bad or worse, and 5 being excellent, what will be the video aspect of how things are going? That will be your entry point 1 in the list structure you're going to give me. You'll say my list equals, and then you will have a parenthesis open, and then there will be 5 entries to it. So the first number will talk about the quality of the video you're seeing. The second one is audio. How clearly am I speaking? Do you hear me? Do you want me to, yell even more? Or how is the audio part coming? And that will be the second content. The third one is content. By content, I mean whatever we have on the slide, whatever the discussions are, how it's coming across to you. And so this will also be a number. So all 3 of these are numbers. Stars, if you like, of something that you review and you like a product and you see some numbers. Think of it that way. So 5 is excellent. I want those 3 numbers, but then I also want something that is give you a chance to say a comment on however things are working. For example, if your internet is poor, you may say that, or if things are going well, you may say that. If things can, so don't write a whole lot of things because you don't have time, and we don't want to necessarily make this one like a big thing, but at least a couple words that would give me a sense for how things are going. So you write my list equals 3 numbers, where each one of them is a number 1 to 5, 5 being the best, and then 1 or 2 or 3 or whatever, however many words you want to write about comment. And this is about how things are going, having seen how the first week has gone and having come to the middle of the second week. That's our warm-up question. We get started with that, and then I will continue to discuss it. So I'll give you a minute or 2 or something like that to see how your experience has been. So keep doing what you do. I will do my chat analytics. That's the word I invented, and I'm very proud of it. So we'll get that one on Blackboard, but I'll get to this one when the class is over today. So I'll give you a minute to complete that, okay? And I appreciate everybody doing an excellent job on how things are going. And I will also assume that coffee drinkers have your coffee already, or it's by your side, and tea drinkers the same way. You are all muted. Feel free to turn on your videos. I encourage you to do that if you feel comfortable. Otherwise, we'll get started. Okay. I'm going to go now because I have seen all 65 of us are trying to type something. And I like the chat feature because it makes a lot of people speak at the same time. So speaking of things that have become positive, I see more engagement because now you get a chance. If we were physically in one person in a classroom, I don't think 70 of us will speak at the same time, but now we get a chance to speak. So remember, the numbers that you would give me are 3. So Colin, you've given me 2 numbers. So audio, video, content, and then the 4th one will be your comment. And so I expect a list of length 4. All right, this is the plan for the day. I'm going to finish off what we started last time, and I will call this one leftover topics, because our goal was to have an introduction to R for this entire week, the lectures and the tutorials together. This is not going to mean those of you who are new to R will have everything that you need to know learn in a week. That will not happen, but you get the basics, and then as we go along, you get to build more and more of them. But this is what the goal is, and it is ambitious. And so I did not get to finish everything I wanted to do on the last lecture, so I will cover the ones that were left over from last time. If things were to go extremely fast and things like that, the second portion of these lectures would have been on R graphics, and I will get to that one. So R graphics is new. The leftover topics are topics that were in the original slides last time, but I didn't get to do that. Yesterday, the first tutorial on this went very well, I heard. And I broke a party to see how things were going. The reason for it was the following. We have the video links for the class on Zoom, and nobody had any problem. So we knew where to go, and so you were there. Office hours for me, I have met with some of you on some occasions, so we knew where they were, and they are on Blackboard. And the information we had, I put together in the first week or the first day, had that information. The tutorials, we didn't want to make them happen on the office hours or the lectures. And so there was a separate link. And so yesterday, while the tutorial was happening, I was in another meeting. And so my email was getting somebody's waiting. And so I felt bad because people were trying to get to the tutorial, but were going to the wrong place. So the recording is available, and it is posted on Blackboard. And Blackboard is something that I think most of you are familiar with, but the way things are structured sometimes may require me to tell you where things are. The recordings are available via the Zoom tab on Blackboard. And if you go there, then you get the meetings themselves, but also a tab that's called crowd recordings. And so the lectures are there. Just like that, for the part that was for the tutorial yesterday, the recording is available. So if you have missed it, and some of you have missed it because you had classes and you had conflicts, which is understandable, then you can go and get it. From what I have heard, Helen told me, there were things that actually made the tutorial being via remote delivery better, because then she can get to display what is on her screen, but also people get a chance to work and things like that. So, and she had 90 minutes yesterday, a little more than what we had in class. So she had covered what would have been the R basics, the one that is not including the graphics part. So for those who have heard yesterday, a little bit of the things that I would be talking about, the leftover topics from the last lecture, are already covered. For those who were not there, then you will hear from me for the first time now. There will be a second portion of this tutorial, and it will be focused on the graphics aspect of it. And that will actually be a good thing, because you've got a lot of chance now to do with hands-on things on graphics part, things that I would just explain using slides here. They would be detailed there. So if your time allows, I absolutely encourage you to attend. And there isn't anything that is as good as live, because you can ask questions and things like that. If you cannot, then the Zoom recording will be made available after it is done, and you can go back and come up and watch them. The advantage of having to attend them live is because then you can actually do the exercises yourself, because you get time to do it. Whereas if you watch the video, then you kind of get lost in between when people are trying and so on. So it's easier to attend live if your time allows it. If not, then we have a substitute for it. It's not just the video of the first part of the tutorial that is posted on Blackboard. The code or the exercises, what you were supposed to do in class if you were to attend, that file is posted. And that is posted under the course content. So you've got the course content place in Blackboard. I've got things called lectures. I've got things called resources. I've got things called tutorial and assignments, right? In assignments, you know what to look for, so you get your assignments. So things are self-explanatory. So if you go to that part where it says tutorial, then you get this document, a PDF file that has got the exercises and the solutions. So if you are going to do this on your own, I would encourage you to probably just look at the line that asks the question and try it yourself. But then the solution is displayed right next to it. Whichever way you learn is fine with me, but it is available. So the recording is video, but this one is just a document. And sometimes it might be much faster for you to learn it that way. That's available. Last time, a good portion of the time was spent me walking you through the R resources document. And there are 3 categories. The last one is videos. I would encourage you to watch them so you would know, because I don't have to spend a lot of time talking about syntax, and that type of thing is easy for you to do over a simple thing. After you have had your dinner or something, you can watch it for a minute. So there are 7 sections. Each one of them got a couple topics. Each one of the topics has got 5 minutes. So if you think like 14 of them, and each is 5 minutes, that would be like 70 minutes. So there's a couple of hours worth of video material there that you can very easily, without having to stress too much yourself, learn. And that way, I will consider that as a supplement. So take advantage of that, and then take advantage of the sessions that Shira did, which I listed there, that you can do that in an interactive way. So you've got very many ways. Don't expect this meeting time now for lecture to be a time when you actually learn the syntax of a language, and that's not a very good use of our time either. So I wanted to mention those points and then get to today's topic. All right, any questions before I get started? Everybody's list is looking great, and I'm assuming that every single one of us, 66 of us, have participated in this. Let me see if you have any questions for me. And silence means no questions, so I'm not going to expect somebody to say no questions. Okay. If you see me turn my faces around sometimes like this, I've got a couple monitors, and so sometimes I want to keep everybody's face here on one screen and have the chat. That's why I turn to watch things. And whenever I am trying to explain, I try to look at the camera itself. Okay, so what we did last time in our marathon walkthrough of our of what it's what it has to offer and things like that was we talked about, just like any programming language, it has got a way to describe data types, basic data types, Boolean, numerics, categorical variables, characters, and things like that. And then, of course, these are variables, but we will deal with collections of things. And so I had this nice summary of things that are about the same type, vectors and matrices, when it's one-dimensional and two-dimensional. And when it's a mixed type of data, it's list and data frames. So vector and matrix we finished last time. List and data frame we did not. But Helen's tutorial has covered this one. So I will talk about lists and data frames in a fast way today. And so the other thing that is not there in the place that I showed you, which is a basic data type and is worth knowing its distinction, is the thing called factors in R. And this is a data type that is meant for categorical variables. What are categorical variables? These are variables in statistics. This is something that you know very well. You have a fixed set of values that you can assume. So there are classes or categories, in other words. And the reason you need a different type of data type, like, for example, instead of just treating them as characters, is because there is different statistical manipulation you want to do around them. You want to group them. You want to have them as categorical variables appropriately. And therefore, there is a data type for it, and it's called factors. And so I'm going to be fast on this one. It's not a collection. It is still one, but it can have value that is one of a fixed number of things. Excellent example, blood type. We've got 5 of them. Or 4 is it? A, AB, O, I think it's 4. So that's the blood type, and so anybody's blood type cannot be out of this one. But if I have you know, a structure that has got these things, and some of them would be repeated, then I could have a vector called blood. And you remember what this C does, it creates, and so I've got a vector, and I can create a factor after I have had a vector. At first, I didn't think of this one as a factor, but I just create it as any other vector. And then I can convert it into being a factor by calling the function called factor. One thing you would notice about R is that it has got function names, calls like this, that are more like exactly the same thing as the data type is. List would be called list, factor would be called factor, matrix would be called matrix. It's the same concept that is used as a function call. Sometimes that's a very convenient thing to do, but you may forget that you're using a function call now, so you may mess up with it. So here is a way that a factor data type is created, the structure, and we called it blood factor, but its input was a vector, and so it would now know what to do with it. So it was a vector, it will change it into this appropriate one. So the thing you need to know about factors is, because it is categorical, then it would have the associated level, as it is called in R, what those categories are, and R will internally represent that, and that's called level. So you may have a vector, it has got some repeated values, but it would extract the things that are levels and then have them name. And they would be by default stored alphabetically. So in this case, you've got A, B, and O, and so they would come in this fashion. You can also create you can change the names of these levels, and you can create the factor, instead of having it to convert from a vector that I showed you earlier, directly by having to say what the labels are and what the levels are. And here's an example that shows you this one. And so you may want to be, for clarity, for somebody who is reading your code, to make it clear that you're dealing with blood type. And so that's what this prefix BT stands for. And so you've got the names of the blood types there. And so this is a valid syntax you're creating, and you have given a name for the levels. That's what the second bullet point shows you. Another way to do this would be to call the factor function with the vector that you are doing, and then you give the labels for those levels in the same line of code. So you've got a couple things, or maybe 3, that you have seen so far to create a data type called factor, and in this case it was about bloods. One thing I want to tell you about factors is that they are categorical variables. They would assume one of a fixed number of things, and when they are not specified any other thing, then they are treated in a fashion that is not ordered, the default one. But sometimes you may have things that have to do some ordering, and so these things are called nominal or cardinal in statistics. And so sometimes the blood type, for example, doesn't have a whole lot of things to say about order, but then the alphabetical ordering of these things is just fine. But if you were to think about some other type of categorical variables, like t-shirt size, for example, is a good one, then the values that you would assume, depending on what kind of system you want to use, maybe you've got only 3 or 4 sizes, and sometimes you may want to cover a whole lot of range of people, and so you may have 5 or 6 of them, but these are categories of sizes, and so you put them small, large, medium, XL, and things like that. And there is a natural thing about them that is about order, and so you can now say that this thing is an order type, and then comparisons, inequality comparisons like this would become meaningful. It will not be meaningful for the blood type data structure I showed you before, for example. And so when you want to care about order like this, you can indicate that in one of the parameters by showing that order is important. And you will say order equals to true. All right, we are now back to that list, two-dimensional thing that I showed you. Vectors, matrices, lists and data frames. Vectors and matrices are taken care of. Lists and data frames, that is what we're going to do now. You will notice that I'm going to be the walkthrough is going to be fast, and you will be patient with me, because the explanations for this and so on will be something that you will pick up on your own. So I'm going to just more like comment on things that are easy to forget, or some side issues, but I will not treat this one as somebody giving you examples and taking the time. That's what the tutorials are meant for. That's what the videos that you would be watching are for. So bear with me if I feel like I'm rushing through things. And we will go to the extent we can today. And if we didn't finish everything we wanted to finish, we're fine. We've got the slides, and I trust you to be able to read the slides and follow along and things like that. So I'll be fast, but I am not going to be too concerned if we don't finish everything. Okay, so what are lists? Mixed data types, and you can create them in different ways. The keyword to use to create a list is list, and you have the assignment operator by now clear to everybody. You created your list. You told me now the 3 numerical values you gave for how video and audio and content is working for you, and then you gave me some comment, much like this one does, except that it has got 5. And so you want to know about its length. That's one other thing that you can do. List is powerful. It is powerful because, first of all, it is a mixed data type. That is one of the powers. But if you take one of the entry points in a list, it could also be a list on its own. So I can have a list, and one of the first things in the list is a list. And so I've got something that is running downwards. I could have a vector. I could have a matrix. I could have anything. And so if you think it that way, you probably don't need anything else. No, you can cover, whatever it is that you may imagine to come to be lists. But as we will see in a second, that is not necessarily the best way you want to organize, because you want to do things to analyze them faster. And so it may not be convenient. Otherwise, if I just told you what lists are, you would probably convince yourself that you don't need anything else. Whatever it is, if I have just one thing, I will have a list of one thing. If I have got 10 things, I'll have a list of 10 things. And each of these 10 things are not necessarily only going to be of different data types. They could be lists themselves, they could be vectors, they could be matrices. And so what else do I need? There isn't anything left because the other dimensions are coming through the entry points for this to be. So know that, but know also that there are reasons why we want to keep them in different ways. So I'm going to give a fun example now, a list that you would create. And in this case, we are going to create a list that has got food type and some numerical values that talks about its nutrition. Names are what you would associate with the contents that you would have in a list here. So for example, after I created this list called food, I can give them name. Because the numbers I told you, they don't mean anything now. So I'm going to say the first thing is going to be type, and the other things are going to be some nutritional values: calories, fat, carbs, and protein, just like what we did for our warm-up question. So I told you to give me a list, and then I asked Brittany to write it again, and I told you what they were. So much like that, I could have said, here is video, here is audio, and here is when, and here is what your comment is. The first 3 are numerical values, and the last one is some characters. So that's a word there. So names is what you are using. Once you have a list, you can get access to its content using the $sign. The $sign is telling you now, and part of this list, much like what you would do in C, and so you say dot, and then you will have a function name or a data type in it. You use the $sign. And after the $sign, you can have the type, the calories and the fat. That's what we just described. And so every time you type those things, what I am showing right next to it is what R would display to you. It will tell you the answer to what this one was. You can also alternatively create a list by having to, at the time of creation, telling what the type is and the other things that I told you. You can do it afterwards by having the names function, or you could do it at the time of creation by specifying parameters already as you do. And this is true of other things, like we saw for matrices and vectors last time. You remember, I told you one of the places where R could be confusing is how indices are used. List is powerful, I told you, and you may want to get to a point in your list, and so you want to access something. If there is one general way I will tell you, whenever you have a list, there is either a single parenthesis access you have, or a double parenthesis access you have. The double access parenthesis is probably the one that would immediately come to your mind. Then you are interested in getting a single element in that particular location. And so whatever that location is, whether you specified with a name or a number was going to come within those two double brackets. If it is a single bracket, what you are getting access is not to an element, but to whatever the content of that one is. As I told you, it might be a list. In fact, the default way in which list would organize itself in R is actually a list. And so if you do a single bracket, then you are having going to get a return of a list of elements. And so there is some direct reference to manuals. Manuals are something that you would go to, you will always have a need for, but in this particular case, I actually wanted you to go and look at it. And so the food example we had before, if I use a single index, parenthesis like this and a 1, I'll get a type and I'll get my potato. But if I get a double one, then I'm going to get an entry, and that particular entry, it happened to be potato. And so the way the things are written now are different. The first one is giving you a list. The second one is giving you an element. I'm going to just show you this. And so when you got the slide, the PDF ones, by the way, I'm not sure if I mentioned this one. The slides today are already posted. So many of you have asked me before because you want to get to take notes as you go. So this was posted if you didn't discover. So now, half an hour later, I'm telling you that it is already there. I'll try to make all the time the slides available before class, 8 a.m. or something like that, if you wanted to browse through before. But I like you to follow along as we do, so I'm not necessarily going to expect to see it. So this is a line that shows you the previous example I showed you to be created at the same time, at the time of creation. And you can see that now you have a type called potato that you've shown as part, and then some numerical value. But if you see the third one, this is a place where you see a list could have contents that are of different types. So the first one was a character, the second one was a numerical value. The third one happened to be now a vector. And so this, is created with a C, and then you've got names inside them. So you have a list where the third element is, in a simple way now, you can think of it as a list. You can do that at the time of creation. And so if you type now this parenthesis, and then you've got a range, now you are accessing a subset of it. And the subset goes from 1 to 3, that means everything. And so the first one happened to be just one thing, the second one happened to be just one thing, but the third one happens to have many things in it, in this particular case, 3, and so you get these values displayed. That's one thing I wanted to show you. Here is a very fun part to get to your 37. That 37 was the carbs content of potato. I'm not sure if these numbers are real. Let's call them real, since it's got lots of carb if you're watching that. So if you want to get that 37, you've got a couple different ways you get there. So the first one shows you go to the third one, pick the second element. The second one does it the same way, except that instead of now putting it in indices with numbers, you have used the names that you have created, the labels that is, and nutrition and carbs was what it was. Notice how the order is important there. So the first thing would give you access to the first dimension, and the second one would give you access to the next one. You could also add something to a list that is going to grow. And so we had our food, and it was defined in this way, but we wanted to add another content to it at the very end, and it's going to be a Boolean one. I could do this just in a single line like this. And some of these places is where you would appreciate the convenience you would get with single line calls. So you had a data structure. If you think about it, you had a data structure and you want to append it with a new one, a colon you're adding in this, or last element. And all you needed to do is have the $sign and a new name that never existed before, and you've got the assignment there. So many things are taken care of with just this single one line. So you have appended, you have grown your list by adding one more thing. That was 100, I don't know how fast I have gone, but a very fast walkthrough through lists. And I hope you have been following. Okay, I told you lists are good enough. And so I would want to use them. If you are in this class, one way or another, you are caring about data sets. So you have things to analyze, you have things to work. And that word is what everybody now says. Sometimes it's a bit confusing what they mean, but you've got data sets, that means you've got observations, many things, and each one of them has got many attributes. There's some variables that you would associate them. So you've had a huge thing. Think of it like a table of some sorts. And so that type of thing is what we work with. And this list I've told you would be a way to get to access to store something like this, but it will not be a good way to analyze it. It will not be systematic. That is what data frames are supposed to do. This is our specific thing. Think of it as a database. Think of it as a way to store information in a manner that would correspond to how we would understand observations, which is like A, B, C, and so on. Like I've got people, and then each person has got different things I want to store about them, their age, their name, where they live, how much they like this class, all that type of thing. So this will be observations. What would be the data structure to capture that? That's what data frames are. So the rows and columns will be a good way to think about them. In that sense, they are more like matrices. But matrices, as you know, would represent the same value everywhere. So I go to the I's row and J's column, I get a number. I go somewhere else, I get another number, if it was numbers. If it was Boolean, it will be Boolean. My data frame is a matrix of sorts because now I have got rows and columns, but each of these different points will have different things. And so, and depending on what those variables were. So rows are observation, columns are variables, and the structure I have now is called a data frame. One restriction we have on data frames, which is a very reasonable thing, is to say every column has to be the same. If I say age, it's age. I'm not going to have a number for somebody and then something else for an age for another person, right? So every single column must be of the same type. Other than that, the columns could vary. Some of the columns could have the same type. If one of them is, for example, I don't know, height, and the other one is weight, they could both be numeric. And if you wanted to have decimal points allowed, they could be of the same type. That can happen, but they don't have to. So they could be different. But within one column, everything should be of the same type. Okay, that's what data frame is. Then how do we create it? Well, just like we've been seeing lists and matrices and vectors and so on, we used that keyword. Data frame is also a keyword in R, except now data and frame are separated with the dots. And so data frame, and then I have created. What I have created here, this example shows you what you probably look like to me. I don't want to think of it that way, but the roster of a class. I've got students, and so here is what they are. So roster is here, and then we've got these different columns created. And you can see now that you could do a whole lot in just that single sentence when it is created. You can say what the column is. The first one, for example, is an ID. Think like your WSU ID, it's a number. The next one is your name, and it happens to be character. And so we show that. And that was first name and last name similarly. And grade now is a factor. Factor is a categorical value, so it is created in this way. So now I have created a frame. In this case, I'm using the frame in the literary dictionary meaning of it. It's not populated, but I have got the data types specified and what it is going to contain. This will be how you would create a data frame yourself. But stop for a moment and think about what actually you may want to do. This is going to, there may be times when you want to create a data frame of your own. In fact, if you're designing an experiment or if you're building something that is going to yet to come, you may do this, but it's very unlikely that you want to start from nowhere like this and populate it. The other way around is the actual case. You've got, and sometimes to your disappointment, things that are existing. Somebody else has created some, so they're there. And so you want to read them instead. But when you read them, now you want to turn them into a data frame. And so you want to be able to manipulate them. And so R has got a couple of ways of doing it. The most common one is called read table. And so you read a table as you know it in a tabular form, rows and columns. So that way now you can get the imported table. It could have been a CSV file, for example, and turn it into data frame. So let me show you a couple commands that you probably have not seen. So now that we know data frame is a matrix of sorts, and that means it's got many, and whether you've created it yourself or read it from somewhere, you would read and you will have it stored in your R, but it will typically have thousands and sometimes hundreds of thousands of rows and so on. But you just want to get a feel for how it looks in the first few things. And so head is a keyword in R. And so if you write head and then the data frame in it, then you get the head of it, right? A few of it. Or you can get a summary, how many observations there are, how many variables there are, what types they are. So these are two important, very friendly things to you that you would want to play with whenever you are working with a data frame of some kind. And then you get to access them. Just like we did with lists, you get a way to access them. And it is kind of intuitive what you would do. The $sign is a way to access the type, and then you specify. So the roster I told you first, for example, to that data frame, I can go and then say write $ and then say first name, and that will give me that column of first names. Similarly, I can access it by having the double, the square brackets, and giving it the name of the label inside it. If I want to get access to within one column and a particular row, then I specify the index for it. And sometimes, of course, you will want to do all kinds of manipulations with it. And so I may go to a place where ID, and then I wanted to find out students who've got A in this class. So I can write things like this. One thing I want to stop here and tell you is we are going to be talking about exploratory data analysis next week, which is a significant topic for us. And then we're going to work with data manipulation the week after. So there's tons and tons and tons of very good libraries that would help you do things like manipulating like this. Some of these things are easy and straightforward. They are more like queries. I want to know, the second entry here, this property satisfied, but they will very soon get very complicated. And so you want to have to work with multiple data frames, something that will be fed from one data frame to another. That is what I mean by data wrangling partly. And so those things will come, and data frames will be the stars. I mean, you would work with them all the time because you have to manipulate them in different ways. I'm going to take a minute now to show you how you may increase it. Just like the potato example we had, we wanted to tell the rest of the world that we are going to add another variable called is testy. And so we just added that with a $sign is testy, and we said it's true. We could have started with a data frame and we want to grow it. And there are a couple function calls I want to tell you how to grow that. So data frame, table. I've got rows and I've got columns. Rows are observations, columns are variables. And so if I wanted to add a column, it means I wanted to have another variable added, and I could do that. So for example, if I had started with a data frame that has got 3 columns, ID, age, and sex, but I wanted to add weight to an existing one, there is a function called, or I could do that by having to create a vector of the right size. In this case, I had started with a data frame that has got 3 rows. And so I could create a vector of length 3 that will be now my new one that will be get added. And then I could add it to the existing data frame. What this particular data frame is called people. And so I have now called weight, and then I'm adding what I just created, 132, 122, 184 for those weights, and that will be added. And so I could, once I have done that, then I can manipulate things any way I want. And so you can see this has happened now, much like how we added the is testy Boolean variable to a list. Much like that, we have added now an entire vector, and that vector just had to be the size, the right size, but it was one way. The other way you could do this is by calling a function called cbind. And bind is bind, as you may imagine, and the C there is for a colon. So I had a structure, it's people, the data frame, and now I am adding a colon to it. I'm binding a colon to it called, I should have said height, I guess. Oh, it's right. I'm showing another example. So it started with 3, ID, age, and sex. The second example showed you how to add weight. And then the next one is showing you how to add height. So in the weight case, I showed you one way, and in the height case, I'm showing you another way. And this other way happened to be called cbind. So if I told you cbind, then you might say, okay, then there must be an rbind if I wanted to add an observation, not just a vector that is a new variable in a way, but another observation. So far I have 3 people, and I wanted to add a 4th one. I can do that using rbind. And so you can add a row in this way, as you can see here. This is manual. This is something that you could handle every now and then when there is only one thing to change or a few things to change. But if you have more things to manipulate and there are different data frames that you're working with, you will probably not do it one at a time in this way. You would rely on libraries, the topic for data wrangling. And this will be a good example to see what that would mean. All right, these were the leftover topics from last time. Today's topic is going to be on R graphics, and we've got 10 minutes. So I'm going to allow you to kind of change your position if you're sitting or you sip your coffee or something like that. And I'm going to talk about R graphics to the point where we can get. This is a good place for me to stress again that you should make sure that you attend the tutorial on Thursday, so you get to practice for yourself. First, the plug for R. R is very powerful in graphics. If there isn't anything else, then this should be a very good reason for having you to learn R. It has got two kinds of things that are relying on third-party libraries and things that are built in within R. And both of them are available. And we've got plenty of things that are third-party libraries or things that would rely on. ggplot2, ggvs, and lattice. Some of these graphics aspects of R are actually an outgrowth of some more fundamental ways of thinking about visualization and how to organize them, and some design principles and things like that. So every single one of these that I'm telling you now has got an associated philosophy, as an associated way of organization and so on. So don't think of them just as, here is another cool library I can add to how I would do things, but also if you are a software engineering type of person, how things should be organized for flexibility and for more powerful expression of things. And so that's the point I want to make with as a passing remark here. One thing I also want to tell you, and we will walk through a few examples now, is R is good at figuring out things from context. So you've got one function name to remember, and then you give it whatever it is, and then it will figure out what the right thing to do is with that one. So I'm going to talk about very basic functions for getting graphics out. One of them is plot, and the other one is hist. Plot is what you may imagine it to be, and hist is something that you would do when you want to see distributions. What is nice is just these two function names, depending on what you're putting in that parenthesis, will make R do the thing that is right for that type of data type that you are giving it. Okay, so we're going to work with car dataset, and Helen is going to have this one for you in the tutorial also. So cars is something that everybody would have some intuitive understanding on, and I'm sure 95% of the class drives car or owns a car if you're lucky. Some of you may have a very old car, that's okay, but you know them. And so some of these things that we specify about their kind of behaviors and these variables would be things that would resonate. But let me first show you a concrete example of where you read a data frame. This is going to be read from a table. And so you're building a data frame called cars now, and you're using that function I've told you before called read table. There's a lot of things that's happening on just this single one line. Those of you who are C or you write something from scratch would appreciate very much what this single line of code is doing. It's going to a website, grabbing a CSV file from that website, reading it into a data frame, and it with this just single one function call. This particular data set is available on the My Labs website. We put it there, and it is tab separated Excel file TSV. And so you go there, or this function call is making it go there, and then have the header parameter set to true, and then it's making another parameter choice there, but it is reading the table, which has got some information in it, some rows and some observations and some variables, and it is turning it into a data frame. There is a function called str, is short for structure, and if you give it the name of a data type, then it will tell you the structure of it. And so in this case now, we've got the cars data frame read. The first thing we want to know about it is what it is made up of. And so this str, structure function in R will tell me what it is. So it's a data frame. It has got 38 observations. It's got 8 variables, and the 8 variables are displayed next. Country, car, miles per gallon, weight, drive ratio, and things like that that you would imagine. Some of them are numerical values. Some of them are factors, like, for example, country, because there are only a handful of countries that are represented in this data set. And these countries, by the way, are manufacturers of that car. Okay. A single line teaches you a lot of things about R now, right now, and so a few functions that you would want to work with. But we now have this in our R where we are working on. So we want to plot. Plot is a generic plotting function, and what it does will depend on what you put in it. So the first thing I want to plot is in my cars data frame, I want to go to a place where it says country, and I say plot country, cars country. This was a factor. It was a categorical variable. So R now will figure out that the right thing to do for this one is to do a bar plot, a bar chart. And there it is. France, Germany, Italy, Japan, Sweden, and US. And then it's telling you how many cars each one of these countries has got. So it's doing a good job. The choice is absolutely right, that this being a factor, the right thing to plot now will be a bar chart. If I say the same thing, plot, but this time I say cars and miles per gallon, and miles per gallon is a numeric one, a continuous one, in fact, then R will decide the right thing to do for this one is an index plot. And so there it is. I'm not going to have the time now to tell you how to make this one nice. It's not nice. The cars are just numbers. Now the x-axis is just labeled index because I didn't tell R to do otherwise, but it at least figured out the parameter, cars miles per gallon, is on the vertical axis, and it is labeled as such. Otherwise, it doesn't look that pretty, but it's very easy to make it really, really nice. If I give it 2, weight and miles per gallon of car, the same function called plot, then it would now figure out a scatter plot is the right thing to do, and I get a scatter plot. All right, we've got 3 minutes, and so the results are intuitive, and we can now also have a plot where we have, like what I showed you before, 2 things and a scatter plot, but the relationship between them is not all that clear. This is some of the things that you would do when you do exploratory data analysis. Sometimes their relationship will be clearer if we do a log plot instead of the plot that's normal. So in this case, we are doing a log both axes on the vertical and the horizontal. And so I've got a log plot, and now you kind of see a relationship, how they are related. Since there's some kind of, once they are in log, one thing decreases as the other one increases type of relationship is seen. All right, I will not get a chance to go more, but let me show you now what plot will do if I give it 2 parameters. In the previous case, where there were 2 continuous ones, so I decided to do a scatter plot. What if I give it 2 categorical values, and in this case, cylinders and country, and I still say plot? R will figure out that the right thing to do will be a stack bar chart here. Each of the categories is in 1. The first one will be the one taking the x-axis, and the other one will take the y-axis. And so in each one, I've got a stacked bar. And so you have now seen the plot one. I have a set of slides that talks about histogram the same way. It will walk you through. And then the other portion of the slides will make you go through these things and make them look nicer by having to specify parameters. I will be happy to pick up a few of the things that are left from here on our session on Friday, but I will also want to use the time on Friday to talk about R Markdown. I've told you this, just mention the name, but you will appreciate having to do that because it will help you produce documents that have got codes embedded in them and the results, and hence the reason for R Markdown. Just as a way of telling you about R Markdown, what is posted on Blackboard on Helen's tutorial, you've got the video, you watch what she does, and she will speak, she will slow down for people to work on and so on. That's the video. But if you see the file that is put under the tutorial folder under content, you will get a file, and that file is generated using R Markdown. So you have a product to see what R Markdown would do. Okay, that's what I will talk about on Friday, and whatever is left in these slides, I will try to find some time to go over. All right, we're just at 10. I have to stop here. Was nice to see you all. If there is anybody who's got a burning question, I can take now. No? Okay, then you are dismissed. I'll see you on Friday, and take care, of course, and watch out. All right, see you Friday.